Welcome back, everyone, and let's now get into the nuts and bolts of this lesson. So the first term or keyword that we're going to explain and make sure you know is species. So here's my little friend, the meerkat, and he or she is an individual member of this particular species. Now, how do we know what a species means? What does this word species imply? Because we use it very freely in our everyday language, but it has a very specific biological meaning. So what do we mean? First of all, they must be able to recognize each other as mates. One meerkat must be able to look at another meerkat and recognize each other as potential mates. More importantly, once they've mated, they must be able to interbreed and produce fertile offspring. That's very important to our definition. They mustn't only be able to produce offspring, but those offspring themselves must be able to go on to produce more offspring. So that's what we mean by a species. But what happens if we start putting lots of members of the same species together? Well, simple. That is called a population. So here we've got our little meerkat and all of his or her friends, and they can mate and they can produce offspring. And we call them a population. So they are members of the same species. We know because they're the same species, they have the potential to interbreed, but here is something extra we're adding to our definition of population. The individuals of the species must live in the same area in order for it to be defined as a population. So we can't talk about the population of meerkats, say, in the Kruger Park, and the population of meerkats in, say, Addo Elephant Park as the same population. They might be the same species, but they don't have the potential to interbreed because they live thousands of kilometers apart. So we refer to them as the same species, but two separate populations. This now becomes important for our investigation into population ecology. We're not looking at all the meerkats in South Africa. We're looking only at a group of meerkats that live in the same area with the potential to interbreed. Let's now focus on our next term. So what then is a community? Well, if you have a look at this picture, you'll see there are our meerkats. That's our meerkat population. But now we have a population of giraffe. We have a population of acacia trees. We have a population of elephant. So a community is many populations. But here's the kicker. It must be in the same area. So the species, collection of the species in the same area, population. Collection of different populations in the same area, that's our community. But we need to go one step further. So what is that? That is talking about an ecosystem. Now you can see here's our population of meerkats. Here's a population of wildebeest. Here we've got a population of acacia trees. So we've got many different communities, but we're adding in the water. We're adding in the stones. We're looking at the fact that there's sunlight, there's soil. There are abiotic factors as well, or non-living factors. So once we add our communities and our abiotic factors in that particular area, we are now looking at an ecosystem. So when we talk about environmental studies, we could be talking about a whole range of different concepts. But for this section of work, we're focusing on population ecology, populations and how they change in a particular ecosystem. So I hope we've cleared up some of the terminology for you. This is a bit of previous knowledge that you should have, but at least now you've got a good foundation for moving forward into the new work that we're going to cover. So here's where we were. We've done our little introduction. What we now need to say is we are focusing on populations, and we're going to move on to this first subtopic called parameters. So before we even start with the biology, what do we mean by a parameter? Let's have a look. Parameters are characteristics or properties. And in this case, we're looking at characteristics or properties of a population. All right? So we're not looking at the word in its everyday English meaning. We're looking at the word as it applies to populations. And there are a variety of different parameters we are going to have to become familiar with. So out comes that piece of paper again, because we're back to our keywords. We need to now investigate what each of these parameters is all about. Are you ready? Let's start with our first one. We're going to go to our very first one, which is called density. Now, you might be familiar with the everyday use of the word density. If I talk to you about hand cream is denser than water, you get the idea that hand cream is thicker than water. Hand cream will float on water. Let's now look at what we mean about density in terms of populations. So here we're referring to the number of individuals in a particular area, if we're talking about a population that is on land, or per unit volume. Here, if we're talking about a population that's living in an aquatic environment or ecosystem. So have a look up there at that little graphic. Here we can clearly see that something is less dense and something else is more dense. Right? So the idea of more individuals means that the density is greater, less individuals, the density is less. So we can see that if this, for example, was our population, number 1, and this is our population number 2 in a different area, we would see that population 2 is definitely denser than population 1. So it all comes down to how many individuals are we fitting into that particular given space. Because remember, populations are all about the individuals in a particular area. Let's move on now to natality. The word natal refers to birth. So when we talk about natality in terms of life sciences and populations, we're talking about the ratio of the number of births to the size of the population as a whole. So we could call it maybe the birth rate. It's the rate at which new little individuals are being added to the population, of course, by reproduction. So it must be adding to the population size, and it has to be by the process of reproduction. Let's now move on to what I would say is the opposite of natality, which is mortality. Do you know what that means? Mortality is the death rate. It's the rate at which our individuals are dying in that population over a period of time. So do you see why I talk about natality and mortality as kind of being opposites of each other? We're adding to a population with birth, and we're taking away from a population with mortality or death. What about these two terms that look pretty similar? Immigration and emigration. Let's explore these terms. I want you to think about immigration as being in and emigration as being exit. So will you remember the I and the E? That'll help you to remember that when we talk about immigration, we're talking about organisms coming into a population. When we talk about emigration, we're talking about organisms leaving a population. Now, a good example to help you understand this is looking at an elephant population. Because what happens with natural elephant populations is that at times when a young bull becomes sexually mature and is looking for a mate, that bull has to leave or emigrate from that population. It has to leave the population because it's not welcome there by the other reproductive bulls. And that young bull will leave its own population and join a different breeding population, and then it will be immigrating into that population. So immigration is, once again, the rate at which new individuals join the population from elsewhere. Hey guys, let me in. And immigration is go away. We don't need you. Leaving a population to go somewhere else. So it's not dying, but in effect, it's leaving the population. But remember that emigration and immigration are always coupled. We're always going to see that if individuals emigrate from one population, they have to immigrate into another population. So we're going to see this flow that happens between populations. And it is usually all about mates. Too many dominant males will want to get young, reproductively ready males out of their population. And populations that have maybe lost reproductive males because of age and mortality will welcome a younger male into their population. So what we've been looking at here are different parameters, different characteristics of the population. What we now need to go and focus on after parameters, we need now to look at fluctuations. We've looked at parameters of populations. Now we need to look at fluctuations. So this word fluctuations, or for something to fluctuate in English, means to change. So as things happen over time, they fluctuate. And so that same meaning of the word fluctuations can apply in population ecology as well. Question though, how do they change in size? What causes a population to fluctuate in terms of numbers? Let's have a look at the answer. It's going to be these parameters that are going to be key in helping us understand how populations fluctuate or change in size. So we've got our population. Of course, we can increase the size of the population by adding new members of the population due to birth. So natality is going to increase the size of the population. In the same way, immigration or individuals coming from elsewhere will also have the effect of increasing the population size. So we can see that if we're talking about changes in terms of increase, we're looking at the parameters of natality and immigration. And I'm sure you know where we're going next. We can take our population and we can say that some of the members are going to die. And mortality is something that is going to affect the population size. Also, if individuals leave the population due to emigration, this is going to decrease population size. So now what we can do is we can look at the whole concept of how parameters are going to change population size. We're going to have two of our parameters increasing population size, birth rate and immigration, and we're going to have two of our parameters, mortality and immigration, going to decrease the population size. So I hope you can see here, learners, how all of those different parameters we learnt about, just what they meant, their definitions, they all come into play, and we are looking at something called dynamic equilibrium. We're going to come back to this concept again and again, but our population is hardly ever static in terms of size. New individuals are being added. Old individuals are dying. Individuals are moving in and individuals are leaving. And so we're going to see that over time, our population size is going to change. I want you to now go away and have a short break. And when we come back, we're going to be addressing the next part of our lesson on population changing in terms of size. So I'll see you in a bit.